find the coordinates of the orthocenter of the triangle. Okay, so to find the orthocenter, we have to know what that means. So the orthocenter is the intersection point of all three altitudes of a triangle. So recall what an altitude means. So an altitude is just the height of the triangle, depending on what direction you're looking at it from. So if we're looking at it over here, the height, you'd go from the tallest point, which would be a vertex, and you have to drop a straight line perpendicular to the other side. Not straight enough. So that would be an altitude. Okay, if I were to draw it from this side, going from this vertex perpendicular to that side, something like that, and then from this vertex to the other side, that would be my third altitude. And of course, I didn't draw these very well, but we're looking for their intersection point. That is what we call the orthocenter. All right, so in order to do this, we actually just have to find the equation of two of these altitudes, two of these lines right here, and wherever they intersect, that's our orthocenter. Now you could find all three if you wanted to, but finding the intersection of two of them is enough. So let's go ahead and let's look at this one over here first. Okay, we want the equation of that line. So remember, to write the equation of the line, you've got to have a point that line goes through, and you also need the slope of the line. All right, so we know that this line is perpendicular to line GH over here. So if I can find the slope of GH, then I can find the slope of the line perpendicular to it, because perpendicular lines have opposite reciprocal slopes. So let's first find, let's find the slope of GH. Now that's pretty easy. That's y2 minus y1 over x2 minus x1. Oh, we don't need that. Oops. Okay, so y2 would be -2 minus my y1, 4, over x2 minus my x1, 4. Simplifying that would be -6 over -3, which reduces to +2. Okay, so I found the slope of line GH. Now I want the slope of the line perpendicular to GH. So we take the opposite reciprocal of that number, which means if it's positive, we make it negative, and you flip the fraction. So that is essentially 2 over 1, so it'd be a -1 over 2. Okay, we found the slope of one of these altitudes. All right, now we know it goes through this vertex. Okay, so we can use the point -2, 4, and our slope of -1/2 to write the equation of the line. Let's do that in point slope form here. Oops, didn't mean to write that. Okay, so we're going to do y minus y1, I'll write the equation, equals m times x minus x1. All right, remember in point slope form, we don't plug anything in for y or for x, but we do for y1, x1, and our m. So let's write y minus our y1. Now our y1 is going to be this point, 4, equals m, and my m is -1/2, we just found that, times x minus my x1, and my x value is -2. Minus a negative just becomes a +2. And let's go ahead and simplify this thing here. So we've got y minus 4 equals, let's distribute -1/2 to everything. So that's -1/2 x, and -1/2 times -2 would be a -2 over 2, which is -1. Add 4 to both sides here, so we get, y equals -1/2 x. If you add 4 here, that just becomes +3. All right, so we found the equation of one of our altitudes. Let's do this again for another altitude. Cleared that off a little bit so we could have some room. Okay, so let's find the equation of this other altitude. Let's go from G to this side, to FH. All right, so for the equation of that line, we know we can find the slope of this line, right? So then it'd be easy to find the slope of the line perpendicular to it, just like we did last time. So let's first find the slope of FH. Okay, to find the slope of FH, we do y2 minus y1. So let's go ahead and use this, and this is our y2 and y1. Negative 2 minus 4 over my x2 minus x1. So 1 minus a negative 2, which is the same as just plus 2. Okay, finding that slope, that would become a negative 6 over 3, which is just negative 2. And we want the slope of the line perpendicular to that one, which would be a positive 1 over 2. All right, so there's our slope. And we know we have a point that this line goes through, and it's right over here at point 44. So let's use that as our point, and we will use the slope in point slope form. So we've got y minus my y1, which is 4, equals m, which is 1/2, we just found that, times x minus x1. X minus, and that would be this x value, 4. All right, let's go ahead and solve this, get it in slope-intercept form. So y minus 4 equals, let's distribute 1/2, that would become 1/2 x. 1/2 times negative 4 would be negative 2. Solving for y, we add 4 to both sides, so y equals 1/2 x. Adding 4 to negative 2, we get plus 2. All right, so we now have a second equation for an altitude. Here was our first one we found. So now we just have to find the intersection point of those two. So whenever you have two equations, you can solve by what we call a system of equations. So let's go ahead and do that for our last step. You can do whatever method you would like. Since they're both y equals, what we can do is I can say, okay, well here is one of the values for y. So if I take that value for y, I can plug it in for y right here. So I'm essentially setting the two equations equal and solving. All right, so let's go ahead and do that. So I have, oh, this is slow, 1/2 x plus 2. And I'm going to set that equal to this one up here, which is negative 1/2 x plus 3. And if I solve that, let's go ahead and add this 1/2 x to this side, and a half plus a half gives us 1 whole x, plus 2 equals 3. Subtract the 2, so we get a simple x equals 1. And that is the x coordinate for our orthocenter, which makes sense because we kind of sketched it out over here. And it does look like the x coordinate would be over here at 1. So we just have to find the y coordinate. And you can do that just by taking your x equals 1 and plugging it in for x either right here or right here, either two of those equations. Let's go ahead and just plug it in right there. So we get y equals 1/2 x, or 1/2 times 1, plus 2. And so we get, for our y coordinate, that's just a half times 1 is a half, plus 2 is 2.5, if you want to write it like that. 2 and 1/2. Or you could write that as 5 over 2. All right, so now we just have to write that as an ordered pair. So we found the coordinates, finally, of our orthocenter to be 1, 2.5. I'll go 2.5. There we go. Final answer.